My name is Jeffrey Frankel, and in this series of YouTube videos, I will show you techniques and tips to reduce the time it takes to deal with questions in Paper 1 of the IB Chemistry exam at both standard level and higher level.
In this topic, you must know how to calculate the equilibrium constant. And you must immediately, when you see a list like this, to be able to decide which one it is. And it's clearly this one, D. Let me give you another equation which is very popular with examiners, and that's the Haber process. It's nitrogen plus hydrogen goes to ammonia, and they're all gases. And that's 3, 2. It is important with an equation like this, which is so popular with examiners, that you can write it out practically without thinking about it. And secondly, the K. The equilibrium constant is NH3 square brackets and the 2 because of this 2, and it's the product on the top, then the reactants on the bottom, and it's H2 3 to the power 3 because of that 3. You must be able to calculate these equilibrium constants quickly, and the same for this one. Then, if you look at this, since this is a constant, if you're then asked about changing the concentration of one of the reactants, you know immediately this is a constant at a particular temperature, of course. And if you increase the nitrogen, you've got to increase the concentration of ammonia. Or if you increase the hydrogen, you've got to increase the concentration of ammonia. Or if you reduce one of these or both of these, you've got to reduce that, because this is a constant at a particular temperature. These are essential ideas in this area which you must understand and be able to deal with quickly. Given what we said in the previous example, then it becomes clear that the rate of forward reaction equals the rate of the reverse reaction, and that must be true at equilibrium. That is the only way the equilibrium constant can remain constant. The rate of forward reaction equals the rate of the reverse reaction. And the amounts of reactants and products are equal? No, they never are. This is a very strange one. Many students seem to think that they can be equal. The only time they would be equal would be in an equation like this one. A goes to B, where K equals concentration of B over concentration of A, and it equals 1. That is a specific example, and the specific example of the equilibrium constant. That would be the only occasion where at all times the amounts of reactants and products are equal. If K is not 1, that completely changes that. The amounts of reactants and products would never be equal. If it's a more complicated equation, and even if K equals 1 or didn't equal 1, it would be a very strange situation for the amounts of reactants and products to be equal. It is rare for the amounts of reactants and products to be equal. So that deals with B. The concentration of reactants and products are constantly changing. No. At equilibrium, they are not constantly changing. The concentration are not constantly changing. The forward reaction occurs to a greater extent than the reverse reaction. No, that is definitely not true. The only statement that is correct for a chemical reaction equilibrium is this one. And remember it, the rate of the forward reaction equals the rate of the reverse reaction. Another question about which statements are correct when it's an equilibrium situation. And of course, you must know that molecules do not stop reacting at equilibrium. This one's a strange one. Only side reactions continue and the main reaction stops. I don't know what they mean by side reactions, and certainly the main reaction does not stop. forward and backward reactions occur at equal rates? Yes, that is true. Forward and backward reactions occur at equal rates. There are as many molecules of reactants as there are molecules of product. No, I dealt with that in an earlier question, that is rarely true. Rarely true. Only in specific situations would that one be true. So, forward and backward reactions occur at equal rates. There are different ways of phrasing this statement, but as soon as you see it, you must be able to recognize that it is true. Another question about which statements are correct for equilibrium situation. And the forward and reverse reactions both continue. That is definitely true. That is always true. The rates of the forward and reverse reactions are equal. Yes, we've agreed before in previous questions that this is true. Concentrations of reactants products are equal. No, as I've made it very clear, this is not generally true. It will only be true in a very specific situation. So 3 is wrong. If you look through this, you can eliminate 3 in B, 3 in C, and 3 in D, leaving only A, which lo and behold is 1 and 2, which we know are both correct. Again, question which shouldn't take more than about 15 seconds if you fully understand the concepts behind equilibrium reactions. If you need to write the equilibrium constant down to help you, then fine, do that. I3 minus, but it may not be necessary. It may be possible for you to see how to do it without writing it down. We're adding more iodide ions, that's there. So we're adding more of those. In other words, that has to increase in order for Kc to remain constant. And that certainly will reduce as well. So those are the two things you can see immediately. The other important thing is this remains constant. Therefore, you can forget A, you can forget C. It's a matter of B or D. Now, does the amount of solid iodine decrease or does the amount of solid iodine increase? The amount of solid iodine is going to decrease because you add this to it and it's going to move in that direction. It's clearly going to use up some of the solid iodine. So you can look at this either from a chemical point of view. You add iodide, it increases the amount of that, therefore this must decrease. Or you look at it from a mathematical point of view and you say you add iodide, so increasing this, therefore that increases and that decreases. The amount of solid iodine decreases and the equilibrium constant remains unchanged. B. Again, one of those that if you understand the concepts behind equilibrium and the equilibrium constant, it shouldn't take more than 15 or 20 seconds to work out. If you have to write this down, write it down. If you can do the whole thing in your head without writing it down, fine. When I read this information and this equation and I see this 10 to the minus 5 for Kc, I know this means that there is very small quantities of NO and chlorine. This is a reaction that generally for chemists doesn't go. The material stays here because if you do the equation for Kc, that's NO squared Cl2 over NoCl squared. This is small, close to 0, therefore there's a lot of that there and insignificant quantities of those two. However, you should be able to see it without necessarily writing that down. That because that Kc is so small, there's going to be insignificantly small quantities of NO and Cl2. So let's see which statement fits with that. Concentration of NO equals concentration in NoCl. No, that's clearly wrong. Concentration of NoCl double the concentration of Cl2. No, that's clearly wrong. Concentration of NoCl is much greater than the concentration of Cl2? Yes, that is definitely true. Concentration of NO is much greater? No, that's wrong. So this is the only one that is true simply because this is such a small quantity. Therefore, the concentration of NaCl is going to be much greater than the concentration of chlorine and the concentration of NO. When you're given a question with a catalyst and an equilibrium situation, there are two things you must remember. First, that the catalyst has no effect on the yield. It has no effect on the value of K, the equilibrium constant. And secondly, the catalyst will affect the rate of the reaction in both directions. Those are two things you have to remember. Catalyst has no effect on the yield or the equilibrium constant, and it has an effect on the rate of both reactions, the forward reaction and the backward reaction. So let's look through it. Increases the yield of nitric acid? No. Increases the rate of forward reaction only? No. That only means eliminates this as a possible answer. Increases the equilibrium constant? No, it does not. Has no effect on the equilibrium position? Perfect. When I look at this one, I immediately go for D. Now, why do I do that? First of all, as I said earlier, C is unlikely to be true because it's 2A goes to C and the Kc is 1.1. So C is out. And then these two strange ones. A is much greater than C. A is greater than C. There is no simple way of assessing whether one concentration is greater, much greater than another concentration, or just greater than another concentration. It's like asking you, is 3 greater than 2, or is 3 very much greater than 2? It depends on the situation. Therefore, I think that you can eliminate A and B for that reason, simply because it's so difficult to distinguish between them. Therefore, that leaves D. But let's do the calculation. Essentially, the K equals concentration of C over the concentration of A squared, and that equals 1.1. Let's now rearrange that. C equals 1.1 times A squared. You can do this much faster than I'm doing it. I'm doing every step. Equals C over 1.1, and A equals the square root of C over 1.1. And you can see from that immediately the concentration of A is clearly less than the concentration of C. That's D. In this one you have to do a little calculation. So let's put the equation down. And they tell you that Kc equals 1.0 times 10 to the minus 5. And they also tell you that the concentration of N2O4 is 1.52. So NO2 squared over 1.52 equals 1.0 times 10 to the minus 5. NO2 squared equals 1.52 times 10 to the minus 5. And as that be squared. And I've said earlier, you may not necessarily have to do all of these steps. And you look at that, and you can see immediately it's not C and it's not D. And you can also see it's not this, because it's the square root of that. Therefore, B is the only answer. And if you got a calculator, worked out the square root of that, you would find it's this. So that's one that takes a little bit more time, because I think you do have to write these things down, and you do have to do a little calculation. but it's not a big deal because this is a very popular question for examiners in both paper 1 or paper 2. And it is important that you have looked at it and carefully practiced all the ideas and issues around it. And that if necessary, you can actually write the equilibrium equation, which is K equals NH3 2 over N2 H2 brackets 3. Okay, whether or not this is necessary for this question, I'm not sure yet. However, it is important that you can do that and you understand the meaning of this as we have discussed earlier in other questions. They do give you a lot of information here, and there's a very interesting statement here. Economic considerations are also important. And as soon as I see that, I started to see that the word cost occurs in 2 of them. And I wondered whether B or D were possibly the answer. So let's look at B and D first. A lower pressure would ensure a higher yield at a lower cost. Lower cost is definitely true. Lower pressure, no. Lower pressure would not ensure a higher yield. With a lower pressure, the equilibrium is moving more towards the reactants side of the equation and away from the products. So B is not correct. A higher pressure would ensure a higher yield at a higher cost. Now, a higher pressure would ensure a higher yield, yes, and it is at a higher cost. So that's clearly the answer. Let's look at A and C. A higher temperature would ensure a higher yield and a faster rate. Faster rate is definitely true. Higher temperature would ensure a higher yield. No, it wouldn't, because this is an exothermic reaction. And with exothermic reaction, when you increase the temperature, the value of the equilibrium constant falls. Let me write that down. Exo, temperature increase, the value of the equilibrium constant falls. So that would mean that the concentration of ammonia would fall and that would increase. Therefore, the yield would fall in the case of an exothermic reaction and a higher temperature. Let's look at C. A lower temperature would ensure a higher yield. Yes, that's true. In case of an exothermic reaction, reduce the temperature, then K increases. So you do get a higher yield. And a faster rate? No. A lower temperature does not give a faster rate. So the original idea of going for B and D and then choosing D was a good one. The economic considerations immediately sent me to the word cost. This is one of those questions where they give you a lot of information and you wonder what kind of complex calculation you're expected to do. The reality is a lot of that information is not needed. All you need to realize is that if the Kc is 60 or even 47, that means the reaction goes really to completion. If you look at it, Kc equals Hi squared over H2 times I2. With a Kc of 60 or 47, that means there's a lot of Hi present and very little hydrogen and iodine. So let's look at these statements in the view of that. Concentration of all reactants and products are equal. No. I've explained earlier that that is rarely an answer. Concentration of reactants are greater than the concentration of products. No, in this case they're not. The concentration of reactants are not greater than those of the products. The reaction as written barely proceeds at this temperature. No, that's not true either. The reaction as written goes almost to completion at this temperature. Yes, that is it. That is it. So you didn't need to worry about the fact that they gave you these 2 Kcs at different temperatures. It's just one of those questions which, if you understand the concepts behind the equilibrium situation, and you understand that a number of 60 or 47 for Kc indicates there's high concentration of the product, and therefore the reaction goes to completion, whereas a number which is 10 to the minus 5 for Kc, and therefore that did indicate that the reactants stayed as reactants and did not go to products. So understand what the value of 60 or 47 or 10 to the minus 5 means for these kind of equilibrium reactions. And that will help you get the answer for many of these kind of questions. D is the answer.
If you found this YouTube video helpful, please say you like it and subscribe to my channel and look at my other YouTube videos. Thank you.